Hey everybody, for today's video, we're going to look at some cracks in the earth that are so large and so deep they can be seen from space. Here's 15 earth cracks that are visible from book number 15, the tectonic fissure of Finthalier. The Finthalier National Park in southwestern Iceland is home to one of the most visible tectonic cracks on the surface of the earth, the rift between the North American and Eurasian tectonic plates. This geological feature marks the boundary where the two continental plates are slowly drifting apart. The movement of these plates, it averages about 2.5 centimeters per year as part of the mid-Atlantic ridge that runs through Iceland. The resulting Rift Valley, which is a few kilometers wide, is one of the few places in the world where such plate boundaries are visible above sea level. The rift is composed of dramatic cliffs with clear visual evidence of tectonic divergence that's happened over the thousands of years. The most prominent crack is more than 7.5 kilometers long and reaches depths of up to 64 meters in some areas. Other nearby fissures contribute to the area's network of visible splits in the Earth's crust. These cracks are not only visible on foot, but they're also clearly detectable in satellite images due to their dark linear contrasts and their shadowing effects in the landscape. The movement of the tectonic plates here has led to repeated earthquakes and the gradual reshaping of the terrain. In some locations, small-scale sinking of the land and uplift events have become documented, shaping the contours of the Rift Valley. These surrounding areas includes lava fields, cracks filled with groundwater, and visible separation zones where past volcanic eruptions have happened. In 2005, a massive geological event happened in a remote Afar region of northeastern Ethiopia, producing one of the most significant cracks in the earth visible from space in the 21st century. It's known as the Dahu fissure. This rupture appeared over the course of just a few days during a period of intense seismic activity. The initial crack was more than 60 kilometers long and in places several meters wide. It formed when underground magma pushed its way to the surface, causing the Earth's crust to split open rapidly. The Afar Depression lies at the junction of three tectonic plates, the African, Arabian, and Somali plates. It is one of the most volcanically active and unstable places on Earth. This fissure marked the beginning of a larger tectonic event where the Earth's crust is in the process of being pulled apart, eventually leading to the formation of a new ocean. This phenomenon is happening on a timescale of millions of years, though, but the sudden formation of such a large crack offered scientists a rare chance to observe the early stages of continental breakup in real time. The fissure formed after a swarm of over 160 earthquakes shook the region, culminating in a volcanic eruption from the Dahu volcano. Instead of a traditional cone eruption, though, the magma moved sideways underground, forcing its way between the layers of crust and causing the land to split. The result was a dramatic scar that's clearly visible in satellite imagery, and researchers from around the world have studied the event closely, using radar interferometry and satellite photography to monitor changes in the landscape. These tools have shown continued deformation in the region over the years since the initial fissure appeared, and cracks continue to grow and new faults have formed. This fissure is a key part of the broader rift system that could eventually separate the Horn of Africa from the rest of the continent. But from above, it looks like a clean dark line that stretches across an otherwise flat and arid terrain. It intersects with older cracks, and it creates a complex pattern of geological activity that tells the story of a land in flux. It serves as a real-time laboratory for understanding how continents break apart and how new ocean basins begin to form, offering some insight into one of the most fundamental processes on Earth. 13. The earth cracks of the Badwater Basin in Death Valley, California. Death Valley's Badwater Basin. It's not just the lowest point in North America, at 282 feet, that's 86 meters, below sea level. It's also home to an array of surface fissures and crustal fractures that are visible from space. These aren't traditional tectonic rift valleys like those in Iceland or East Africa, but rather surface-level cracks caused by a mix of salt deposition, tectonic tension, and extreme climate. The Badwater Basin lies within the Basin and Range Province. This is a huge region in the western United States, and it's characterized by a series of roughly parallel mountain ranges and desert valleys. This entire area has been subjected to crustal extension for millions of years, pulling the land apart and forming a patchwork of fault lines. The normal faulting in the region is responsible for the valley's extreme topography, and in Badwater Basin, this stretching is compounded by the deposition of salt from evaporated ancient lakes, which leaves behind large salt flats and polygonal fracture patterns. During some dry periods, the salt crust undergoes thermal expansion and contraction, which forms cracks that resemble a network of white scars. These salt polygons are typically a few meters in diameter, but larger fissures have also been observed in satellite images, running across the flats and intersecting with fault lines at the basin's edge. The low vegetation here and the bright surface albedo of the salt makes these fissures stand out in aerial photographs, especially in high-resolution imagery. Beneath the visible surface, though, Death Valley does also have some fault lines, including the Furnace Creek fault line system and the Southern Death Valley Fault. These contribute to occasional seismic activity and gradual deformation of the valley floor. While the valley's overall tectonic activity is slower than in places like the East African Rift, it is ongoing and measurable. This slow rifting and associated land subsidence contribute to long-term instability in the salt crust and the formation of additional cracking. Although visible cracks at Badwater Basin are not massive canyon-like splits, they are nonetheless prominent enough to be mapped and monitored by satellites. Their highly regular and angular shapes also attract some attention from photographers and geologists, of course, as they resemble man-made geometric patterns. So, as such, the Badwater cracks serve as a surface-level record of both geologic and climatic forces, clearly visible, even in moderate-resolution orbital imagery. This makes it a crucial case study in both earthquake science and climate geology interactions, visible even to orbiting satellites tracking the shifting crust. 12. The Jidatan Earth Fissure, Tibet Plateau in China. In the high-altitude region of the Qinghai-Tibet Plateau lies the Jidatan Earth Fissure, one of China's most prominent examples of active surface cracking caused by tectonic and cryogenic, that's freeze-thaw cycle process. This fissure is located in the Kunlun Fault Zone. Now, this is an active tectonic region that marks the northern boundary of the plateau, where the Indian and Eurasian plates converge. The Jidatan area has experienced a significant number of earthquakes, and the resulting stress on the crust has led to long, deep cracks. Now, the zone was brought to international attention after the 2001 Kunlun earthquake, which had a magnitude of 7.8, and that event triggered some dramatic surface ruptures over a 400-kilometer stretch. Some of the fissures that formed were up to 2 meters wide and several kilometers long. These cracks cut across roads, they altered water flow patterns, and created displacement zones that remained visible decades later. Geologists studying the fissures here use tools like synthetic aperture radar and GPS networks to monitor the movement and expansion of the cracks. The data helps researchers understand how stress is transferred across the Tibetan Plateau and how major fault systems like the Kunlun Fault evolve over time. The location does also offer insights into how tectonics interact with climate-driven geological process at high altitudes. But from a satellite perspective, the fissure is most notable after snowfall or rainfall, when the moisture darkens the cracks and enhances the contrast. The fissures tend to follow linear paths reflecting the alignment of fault traces beneath the surface. Though the region is remote and sparsely populated, this activity is globally significant due to the scale of the tectonic forces involved. The fissures here are not just passive scars, they're part of an active and evolving tectonic landscape that continues to form the Earth's surface. This makes it a crucial case study in both earthquake science and climate geology interactions, visible even to orbiting satellites tracking the shifting crust. The most famous and destructive earthquakes in Californian history have happened along this fault system, including the 1906 San Francisco earthquake, the San Andreas Fault, California. The San Andreas Fault. It's one of the most famous and one of the most studied and one of the most visible fault lines in the world. It stretches about 1,200 kilometers, that's 750 miles through the state of California, and it marks the boundary between the Pacific and North American plates. It's a transform fault, meaning the two tectonic plates slide past each other horizontally. Now, this ongoing motion, at a rate of roughly 30 to 50 millimeters per year, creates a massive linear scar across the California landscape, visible both on the ground and from orbit. From the Gulf of California in the south to Cape Mendocino in the north, the San Andreas Fault runs through a wide variety of terrains, from desert basins to mountain ranges and agricultural valleys. In Southern California, it is particularly visible in areas like the Carrizo Plain National Monument, where the fault cuts a remarkably straight line across grassland and hills. And this section includes features like offset stream channels, sag ponds, and pressure ridges that demonstrate the horizontal motion of the plates. In satellite images, the fault often appears as a dark linear groove or a subtle color contrast following a straight or gently curving path through the terrain. The most famous and destructive earthquakes in Californian history have happened along this fault system, including the 1906 San Francisco earthquake. That event caused a surface rupture of over 470 kilometers, that's 296 miles, and it permanently offset fences, roads, and entire sections of terrain by as much as 6 meters. Even in the absence of a recent quake, the San Andreas Fault is a site of continuous geological deformation. Subtle changes in elevation and horizontal movement are monitored using satellite radar and GPS, which have revealed slow, creeping shifts along certain segments. The fault zone is divided into 3 main sections: the northern, the central, and the southern segments. The central section near Parkfield is known for small, frequent quakes and aseismic creep, while the southern section running near the Salton Sea is overdue for a major rupture, according to geologists. Because this segment hasn't produced a significant quake in more than 300 years, it's under intense observation. But from space, the San Andreas Fault stands out due to the dramatic difference in landforms and vegetation patterns on either side of the fault. Satellite imaging, especially during early morning or late afternoon passes, reveals long, continuous shadows along the fault scarps and clear topographic displacements that trace the path. It's a visible expression of a continental scale plate motion. The San Andreas Fault remains one of the clearest examples of a large crack that defines a major geologic boundary, and its activity continues to shape the landscape of California.